So once you are done with inventory, the next step is to find out, okay, for each of these input and release that we have identified in the inventory stage, what is the environmental and human health impact? That's what I'm trying to find out. So when you talk of health impact, sometimes people talk of not only human health, but also ecological health. How does the environment get hurt? And we are also talking about a term called resource depletion. When you use coal, when you use copper, when you use iron, when you use gasoline, right? The earth has that much less. It's not an infinite source. And so for some materials like coal, we have enough coal to last us another 200 years. There are some materials like copper or zinc that may not last beyond 50 years. Resource depletion is another important environmental impact indicator that we are concerned about. Because remember, sustainability means that not only us, but subsequent generations of human and other life form can enjoy life. So life cycle impact analysis basically tries to provide a linkage between product and process and their environmental consequence. Now, closely tied to impact analysis is the concept of what we call a stressor. A stressor or stressors, they are a set of conditions that may lead to an environmental impact. For example, release of greenhouse gases may lead to global warming. It's not definite. It's very difficult to have a definitive answer, which is why there's a debate about, scientists about environmental anything. So we are careful to use the word may cause this. We have various kind of indicators that we use to quantify environmental impact. So each of these can actually produce a number for you. So you can compare, regular pencil versus mechanical pencil. It's not qualitative. The first is global warming potential. That's probably one of the most important of the indicators we use, and it's a global impact. Then we have ozone depletion. That also is a global impact. Resource depletion. Yeah, it's not, if we are out of copper, it's not going to pinch only the US economy, but the Chinese and the European and the Asian and so on. Now, other impacts are somewhat regional or local. For example, we have photochemical oxidant creation potential. Sounds fancy, right? It means smog. Smog, it may impact LA but not San Diego. So it's very regional in impact. Then we have this term called acidification. Oxides of nitrogen and sulfur that ultimately become acid and fall in rivers and other bodies, and they are pretty toxic. Well, it may be felt regionally, but not nationally. Eutrophication is again buzzword. It means when we release as a result of processes liquid residue in the form of nitrates and phosphates into the water body, those are like fertilizers. They cause an accelerated growth of water plants. Those plants, because they are increasing at a great rate, consume a lot of the oxygen in the water. They then choke the fish and other water organisms. Not desirable. But that influence is felt very locally, right? It's maybe in Lake in McQueenie, right? It's not felt anywhere else, only in New Braunfels. So we have different impact categories, many of which we will measure to compare 2 or 3 different product or process options. The last step is life cycle interpretation. So you got your inventory information, gobs of data, you got your interpretation based data, again, a lot of information. What do you do with it? So now you are evaluating this data and asking yourself, what does it mean? So that's the step. As a result of that evaluation, you should be able to answer this question. We set some pretty lofty ambitions during the goal definition stage. Does our data suggest that with our current product design or process design, we're able to meet that? If not, What about option B and option C? Are they looking like better choices? Um, so we want to be able to identify at this stage in this life cycle which stage dominates. Is it the mining stage? Is it the transportation stage? Is it the manufacture? Or you are looking at, is there any one particular process in the making of engine cylinders? Is it the actual casting process, or is it the mold making process, or is it the subsequent cleaning of the casting process? So oftentimes when we have the impact data, we draw ourselves bar charts. So what you see here, shown in different colors are different stages, right? The dark, this is for the leather, shoe or footwear making process. Cattle raising, slaughterhouse, tannery, footwear manufacture, waste management, transportation. Now some of these look identical, like the waste and cattle raising, because they were actually in color, and I made a photocopy in black and white. They both show up as black, but ideally this would be colored bars, so you can see 100% of global warming potential due to footwear manufacture. A good part of it is caused by cattle raising. The next step, tannery, is very little, right? So what does it tell me? While tannery does lead to some global warming potential, it does not make any sense to obsess about that. Go for the big impact. Or if you're talking about eutrophication, right? You're looking at this. In this case, tannery is what accounts for a bulk of this. So each of these bars represents a particular impact category, like global warming, acidification potential, eutrophication potential, and so forth. The shaded bars show different stages. So we can answer these questions about which particular life stage dominates or which particular process dominates, and which environmental impacts are identified. Maybe for a particular process, eutrophication is not a concern. Global warming is not a concern, but acidification is a big deal, right? And we're also looking to see, well, did we come across not so expected or unusual results? So those are the kinds of things that happen during interpretation, and that's a stage where decision makers can say, well, product option B is better than what we're doing right now, or what we have been doing is pretty good, no need to change. But life cycle analysis gives you an objective manner in which to make those comparative decisions in product and process selection.